This is Lab 2 for Physics 2212. The purpose of this lab is to determine the charge on a piece of tape using the line charge model and compare this to the point charge model and determine which is more accurate. To do this, we'll need the equation for force of gravity and Coulomb's law, both in the context of Newton's second law for forces. We'll also need this formula, which is needed for determining the electric force produced by a line. We also found that the use of the line charge model was much more accurate than the point charge model. For the system in this experiment, we'll be considering a single piece of tape in equilibrium. The experiment for this lab was repeated from Lab 1, where two like charges of tape were placed near each other, and the distance that they repelled was recorded. Since the tape is in equilibrium, we can say that the force of gravity equals the electric force, so we can use this to find the charge of the tape. We will neglect air resistance, and we will also assume that the two pieces of tape have the same charge and that the charge is equally distributed across the tape. After finding the length and the mass of the tape, the charge can be determined by using Coulomb's law for a point charge force. We will compare this value to the line charge value later. Here's the glow script code for this charge model. We expect that the line charge model will be more accurate than a point charge model because it will be better at calculating the superposition of the electric field. First, we'll input all the constants. Then we'll make a function to model a line with a charge with many small points with charge. Then we will set this function to determine the electric field from many small pieces on a line with charge. Then we'll find the force on each of these pieces. Finally, the model outputs the magnitude of the force of gravity and the electric force of the tape. Now we can compare the two models. The charge of the tape was determined once from the point charge formula and once through the line charge formula. From the outputs on the model, using the charge from the line charge model was significantly more accurate by two orders of magnitude. From this, we can conclude that the line charge is more accurate. This is because the line charge model splits a line with charge into many small points, which will then be more accurate when summed into the superposition formula. Sources of error from this experiment may include our assumption that the two tapes will have equal charge, and that the charge is equally distributed across the two pieces of tape.